Okay, continuing on with question number 10. Whoopsies. It says using the real image distance and the object distance determined in data table 4, calculate the linear magnification of each microscope length. So that's pretty straightforward. Here is the equation, which would be right here. Okay. So we go up to data table 4. And then if you remember, in my example, I used 6.9 for my object distance, and we calculated that to be 18 for my real image distance. So for the 30 centimeter microscope, I'm going to use 6.9 for my O and 18 for my I. So down here, I will calculate it. Okay, so my O, I said, was equal to 6.9. And the image distance was equal to 18 centimeters. So the linear magnification equals negative I over O. And the negative sign is just because the object and the image are on opposite sides. It's convention. Negative I over O. So I is 18. O is 6.9. And that equals 2.6. So back on my sheet here, for my linear magnification, my 30 centimeter microscope, I just write 2.6. And then using the data for the 35 and the 40 up here on your data table 4, just calculate the linear magnification of the 35 and the 40. Question 11 says to calculate the angular magnification of the eyepiece lens. And that's even easier. The equation is just 25 centimeters divided by the focal length of the eyepiece lens. So back over to here. So the angular magnification equals 25 divided by the focal length of the eyepiece, which equals 25 divided by 10, which equals 2.5. So back on my question 11 answer, I'll just write 2.5. And again, I'll do the same calculate. Well, actually, for question 11, the focal length of the eyepiece doesn't change. So you know it's going to be 2.5 and 2.5. There'll be all three of those answers will be the same. Last but not least, it says calculate the overall magnification of your microscope. So for my 30 centimeter microscope, the equation here is the magnification of the objective lens, which I calculated to be 2.6, times the magnification of my eyepiece lens, which I calculated to be 2.5, and that equals 6.5. So my overall magnification at the 30 centimeter length is 6.5. And you just do the same calculation for the 35 and the 40. Again, remember, using your own numbers if you are using different numbers than me, if you're using your experimental numbers. 13 and 14 is basically, just answer it in words. And then 15 is basically the same drawing as up here, question number 8, except for that you add the eyeball. Some people have asked me about question 14. Let me explain that a little bit. So I've copied the question here onto a Word document just so I could write while I'm talking. And it says the distance measurements were made in your microscope lab from the end of the tube. So as you remember, you made a paper tube, right? And then we had a piece of paper with some writing on it. And then you measured the distance from the end of the tube to the piece of paper. And that was your objective length, O. But technically, you're supposed to really measure your objective length, O, from the lens, right? Because, you know, in all the work that we've done, we've always measured from the lens to the object, right? Not from this weird paper tube thing. So the question asks you, how would this difference, that is this difference in distance here, right, for the paper, the part that the paper tube stuck out, how would that difference affect your answers? So just think about it, critical thinking. Instead of an O of that long, instead of an object distance that long, you'd have an object distance, the real object distance is that long. So how would that affect your answers? So think about that and write your thoughts in to question 14's answer. And that should complete the experimental part of this lab.